Hey there, David. Can you hear me? I can't
What's up,
hear
dude?
you. There we go. There we go.
There you are.
Cool.
Hey,
Yeah.
what's up, dude?
How you doing?
Good. Just finished up some all my bulk inoculations, so chilling.
Good to
How
have
about
that
you?
done with.
Yeah, it's all good.
Yeah, not a lot going on. We just went and got some sawdust pellets. It's been getting ready to do this.
Nice. How many do you get at a time?
I think it's 40 bags.
Okay, not too. That's like a ton.
Yeah.
I usually buy just like 10 at a time because I have such limited storage. So I'm like, how about just 10? And the wood pellet shop is so close. I don't mind driving over there.
Looks like we got somebody else with us now. That's good. This must be working. So I'm sure the Flourish guys will be here in a minute and we can start running through some questions. Appreciate you guys tuning in, and I'm glad this is working out.
Yeah, I'm excited to hear what they have to say.
Yeah. You have a market this weekend?
No more markets until March. I think I'll start back up at Shemansky, but no, just my regular stuff. I think we're up to like 60 to 70 pounds of deliveries a week right now. So
Dang.
it's all right.
Oh, yeah, that's great.
That's good. I'm happy. I'm really happy about it.
Yeah.
Hello.
Hey there, Joe. I can hear you. I can't see you.
Okay, maybe my. All right, Eric
There
and
we
I
go.
are both here. Is that too bright?
Sweet. I appreciate you guys coming on.
Are we blown out like bright?
A little bit.
How can we fix that?
I mean, it's just super bright behind us.
Is there a way to like?
I think it's okay. We can
Yeah.
you can still see us.
Oh,
Yeah, we'll live.
is there a setting?
Yeah.
Make it less bright. It's right here.
Yeah, that's fine. That works.
I appreciate you guys joining us today, and I did want to remind everyone that this is being recorded for educational purposes, and if everybody can hold their questions until the end, if we have time, we'll dig into that. I'm here to welcome George and Eric from Flourish Labs in Portland, Oregon. This is for the Pacific Northwest Mushroom Producers Network, and we'll just go ahead and jump right in. George and Eric, if you guys want to tell us a little bit about yourselves, your backgrounds or educations, and kind of what led you into the world of testing or mushrooms.
Sure. I'll go ahead and start. I got my PhD in molecular plant sciences from Washington State University in 2006, biology degree from Indiana University in 1999, and really was interested in plants and fungi from the beginning. Right when I went to school, I was either the medical track or the plant route. And because of some interests I had at the time, I went the plant route and got exposed to some really cool mycology courses as an undergrad, and then just went the plant biochemistry route afterwards, and then went through a pretty interesting career. About 15 years in is when I started Flourish Labs. It was in 2021, I believe, when I started doing the work. I think we opened January 1st, 2022, and or 2022. And during that time, before that, I worked up in Seattle. And when the whole medical cannabis and legal cannabis happened, I almost started a cannabis testing lab. And but I was pretty early in my post PhD career, and thought I was going to be doing biopharma stuff for forever, since that's what I did my early career on. And I ended up regretting that pretty hard, that I didn't start a cannabis testing lab in like 2013, 2014. I saw a couple people that I helped have tremendous success with that. And then I moved to Portland a little bit right before the pandemic, actually. And once that kind of chilled out, that's right when all the legislation happened in Oregon for medical psilocybin therapy. And I had a couple friends actually call me and say, you should start a mushroom lab. And so I did. And at that time, actually, I was working as the director at Rose City Labs, which is where I actually met Eric. And he was the previous director at Rose City Labs. And I was only there a short time. And when I was leaving there was right when I was getting the idea going for Flourish. And I said to myself, I was like, I hope I can hire that guy or work with that guy again someday, because, I was very impressed with the short time we did work together. And, now we're business partners. So that's kind of how I ended up there.
Sure. My background, I've been a chemist for many years. My degree's in chemistry. I didn't go to any grad school, but I did go straight into industry. I've always been fascinated with instrumentation and chemical analysis. So that's kind of my deal. Like George said, I was the previous director before him at Rose City Labs, and I worked there for 5 years previously, developing that lab from a cannabis potency only to a full-featured, cannabis potency, solvents, metals, pesticides, all of those things. I developed all those programs for that laboratory.
And accreditation.
Yeah, and the accreditation too. And then, kind of went our own ways. And then turned out George needed some help with some of his equipment. Fixing equipment is my strong suit. So he got in touch, was able to get it fixed, and we kind of hit it off from there and are still working together today.
Great, guys. That's awesome. Very cool. So what type of gap did you guys see in the industry, I guess, that made you say that somebody needs to be doing this? I know you kind of touched on it a little bit, like coming out of cannabis, but I see you guys doing a really wide range of chemical analysis also. And I'd say it's a lot broader than a majority of the other people offering similar testing, I suppose.
Yeah, it sort of evolved out of necessity. Initially, I had planned on just having a, psilocybin testing lab and hopefully testing samples for, the therapeutic side of things. But the cost to get accredited by the state of Oregon for psilocybin therapy was like $10,000, and you had, I think it's per year.
Yeah, $10,000 per year, just for the accreditation alone. Plus, then if you're going to be an accredited psilocybin laboratory, you have to follow the specific rules, and that would limit our ability to do all of the other things that you just mentioned. So, by kind of going more the route of being doing as good of a job as we can, but not being so strict on our regulatory compliance, that means that we're able to provide more services to people, like all those other tests that you mentioned.
Yeah, we basically function like an accredited lab with no accreditation. And this was before Eric joined, there just wasn't enough volume, period,
Exactly, yeah.
From all the samples I was testing, let alone people that were like licensed. So the return on investment was negative by far. So I never really pulled the trigger. Whereas a lab like Rose City, who has huge income from multiple different streams, they just pay the accreditation and then do the tests. What I would assume is at a loss. I don't think they're testing $10,000 a year of accredited, licensed psilocybin therapeutic samples. I don't even think there's that many in the entire state. So I started broadening the testing into some functional mushrooms that were legal, like Amanita was a huge revenue stream at first. Then I did cordyceps and chaga and reishi and lion's mane. And then we started getting into, well, I started doing this along the same time, different DMT molecules, the 4-ACO or 4-OH, the synthetic molecules that people were testing for because they were making products that they tried to make non-detect by a PC or a psilocin and psilocybin test, or people that were trying to show that they actually had psilocin and psilocybin in their products as opposed to the synthetic molecules. And then people will call me and be like, do you test this? And I no, would you like me to set it up? And so what we do is if people come and contact us and have some obscure test, we really won't do it if it's a one-off test and they're going to do it one time because that's silly. But if we think we can generate multiple customers, or if one customer is going to come back regularly, we'll put an obscure test up just to help people out, And one of the things that we can do and operate that way is not being fully accredited in any way, is we have the flexibility to test whatever we want, and gray or black market, whatever. We can do all kinds of different tests with the main reason is like we want to make sure that people are getting safe products, because people are going to be taking these things no matter who tells them not to. But we can offer services that ensure they're going to get safe substances.
Well, that's amazing. I mean, it's crucial work. I'm very thankful that you guys are around.
Appreciate it.
So can you describe Flourish Labs or your mission kind of in one sentence, or just kind of give us a basic of what you would call what you're doing?
One sense, I would say like safety and accuracy.
Safety and accuracy of bioactive compounds from all sources, plants, animals, synthetic, whatever. We just want to make sure that people are getting what they say they're getting. Whoever's selling it knows what they're selling. Whoever's buying knows what they're buying. They know the dose and they know the safety profile.
And what type of things are you guys testing for right now? I know it's kind of broad, but can you kind of just give me for the listeners?
On the functional mushroom side, we do cordyceps, lion's mane, reishi, chaga, and beta-glucans, and then a couple molecules like ergosterol and ergothioneine. Mm-hmm. Anything else on that side?
I can't think of anything else at the moment. But hercinones. But yeah, mostly, each specific functional mushroom will have some compound that is like the one that people are looking for, to be able to quantitate to say, yeah, we have this many milligrams of that compound in there. So in those, that's what we're looking for.
And then on the other side of things, we do psilocin, psilocybin, the other tryptamine alkaloids that go along with that, baeocystin, norbaeocystin, norpsilocin. We do NN-DMT, 5-MeO DMT, 4-ACO DMT, 4-ACO DET, 4-OH MET. Then there's also LSD, cocaine, ketamine. We're setting up a new deschloroketamine test right now. There's probably more. I'd have to publish a list or something. But, to be honest, it's not something we really put out there for everyone to see. Like, there's not a lot of places that do testing like this. So people come and ask, what do you test? Or do you test this? And we either say yes or no. It's kind of a, I don't want to say touchy, but, we test things that aren't legal for sure. And we'll be happy to do those things for people if they can get them here to the lab and make sure they have what they say they have. And we're actually really soon, we're hoping to get into a more broad testing with things like microbials and we're really soon hoping to build the lab out into a fully, a full suite where we do metals and microbes and potency testing and everything all under one roof. But some of the, that equipment's pretty expensive, and we've been bootstrapping with no investors the whole time and just trying to, keep the company ours and do it as we can afford to develop new technologies.
Well, you guys seem to be doing great work, and I'm you're doing life-saving work potentially too. So I thank you for it. So I guess my next question, you guys test extracts that are basically just solvents that have been dried after they've been used to dissolve specific compounds. And as I understand, testing an extract has a lot of similarities to making an extract because you need to dissolve it in a solvent to be ready in your machines. Does that make sense? Like you guys might have a pretty good understanding of extraction just based off of how you have to work with these chemicals?
Yeah, exactly. So making an analytical sample is basically making an extract, yes. And what we have to do is make sure that we are extracting as much as we possibly can from the sample, because that's how we get accurate results. If it's left behind in the sample, then we're not going to see it on the instrument, and those results would end up being lower than they would be, if we had done a proper extraction. So yeah, in that case, it's exactly like it, and it's very important that we get the maximum amount out from the sample so that we can give the accurate result.
Totally. And that kind of leads me into, I guess, my next question is like, I think there might be some fundamental principles that go into extracting a majority of compounds, like your solvent choice, heat, time, and stability. Could you elaborate on any of like the factors that go into extracting a compound and how that might differ from compound to compound?
Sure. So the way I do it, and I think Eric would agree, is the first thing you do is you look at the compound that they're interested in. The customer's like, I want to extract psilocybin from the mushroom, for example. So what you do is you look at the molecule and you look at its natural properties. Is it a water-soluble molecule? If it is, then you use an aqueous extraction. Is it a non-water soluble? Then you go, okay, now what solvent is going to be better to pull it out? Because the different types of organic solvents have wildly different properties and the ability to extract things from tissue. I can give you an example. When you're just extracting plants, if you use an alcohol, you extract massive amounts of chlorophyll. And usually you don't want to do that because that is extracting a contaminant along with your target molecule. So you'll want to add a specific extraction method.
Yeah, and like in the case of the analysis, the chlorophyll wouldn't be a problem, but in the case of something that we want to give to a customer, that might be an issue. So there's a little bit of difference there, where in the analytical side, we want to make sure that we just get everything, and for a product, we might not have that same extraction. But yeah, solvent choice, pH, temperature, time, particle size, like agitation or sonication, those are all important factors.
And when you're extracting from a organism, the cell type is also important, because some organisms have much stronger cell walls or material in them that makes it harder to bust open the cells.
I was gonna ask about like polar or non-polar compounds. I guess if you could classify all compounds into like those two categories, but then you mentioned how like an aqueous extract compared to like something you would use a different solvent on. What type of variability comes into that solvent choice, or how do you go about choosing that solvent for the non-aqueous extractions?
So the few things that I would consider there are, so the general rule for solvent choice would be that like dissolves like. So non-polar solvents are going to dissolve non-polar compounds, and non-polar still has a fairly large range to it. So there's, you could consider a solvent like ethyl acetate or ethanol, for example, as a fairly polar non-polar solvent, I guess, whereas something like hexane or petroleum ether or something like that is like super non-polar, and you won't get anything polar at all. So I'd say it's better to think about polarity rather than as two extremes, but as a continuum between the two. And you want to get a solvent that is well matched to the polarity of your sample, or whatever compound you're trying to extract. And then another thing to think about is that many natural compounds are pH sensitive. So alkaloids, for example, are basic, and in their free base form, they're very soluble in organic solvents, non-polar solvents. But in their ionized form, which would be at low pH and acidic solution, they're much more soluble in water and less soluble in organic. So that's another thing to keep in mind.
That's one way also that we exploit extractions and how we purify things when we manipulate their charge by using pH.
Very cool. Very cool. So, I mean, is there much of a difference between a cannabis testing lab and like a mushroom testing lab or any chemical really? Or is there going to be a bit of overlap here in terms of the equipment you're using, your processes?
Yeah, it's quite similar. If you go to any, analytical testing lab across the country that's looking at small molecules, especially if it's for plant derived or something like that, mushrooms or some organism, it's all very similar. It just comes down to the specifics we've been talking to the last few minutes of what you will use to go after whatever specific compound you're looking at. But yeah, the equipment is similar, the techniques are similar. Everybody gets trained quite similarly coming up through school. And one cool thing about chemistry is it's kind of like math. It's either like pretty much right or wrong. Like they have very specific behaviors. Chemicals are going to behave in the same way day after day after day. And as opposed to something when I have a biochemistry background where I often dealt with organisms used to grow our product, to using a cell line to produce a peptide or a protein. There are different factors in there. Different cell lines will do different things that might cause your product to be different, which is a different challenge than when you're in the chemistry world where there's a lot of physical rules that are established. Now, you can do things in the lab that cause weird things to happen, but if you do the same thing over and over, you're pretty much going to get the same results. So everybody uses the same pool of techniques and technologies to get at these answers.
Yeah. To go back to your question about analytical techniques, you can kind of think about, like most laboratories are going to use some type of liquid chromatography to separate and detect these molecules. And those techniques are so broadly applicable. You can kind of think about it as like learning how to drive a car and then going different routes to different places, where you use the same skills to do those different things, but you're going to end up at vastly different places. For every sample, you're going to be weighing out a sample, extracting it in solvent, putting it in a vial, loading it on the instrument, and then separating it on a column and detecting it with a detector. Now, what parameters you use to separate it and what detector you use, it's going to be a little different for different samples, but the overall technique is very similar between any of those samples.
That was actually another question I had, I guess, is and you just touched on this pretty good, but how does HPLC work? I mean, could you maybe run over that again just in a little more detail?
Absolutely, yeah. So HPLC stands for high pressure or high performance liquid chromatography. And in liquid chromatography, what we're going to do is we have the sample in a solution, so dissolved in a solvent, and then we inject a small amount of it into a column which has a liquid mobile phase flowing through it. And inside that column, are particles which are coated with what's called a stationary phase. That stationary phase has an affinity for the different molecules, and you choose the mobile phase so that it kind of wants to move them, but not really fast. And the interaction between the analytes that you're looking for, the different chemicals that are in there, and the stationary phase determines how quickly they move through the column. So when it's injected, they're all together dissolved in that sample, and then as they move through the column, they separate out and they reach the detector one at a time. And then as you get the signal from the detector, you can say, okay, that signal is this big versus this big, and that's how you can determine what your concentration is of those various compounds that are inside.
And it's also based on purified standards that we make a calibration curve for before we run the unknown samples. So you'll have maybe a 1 part per million to a 500 part per million standard curve. And then you make sure your sample falls within that range. And then you use that standard curve to determine the concentration based on the area under the peak.
Totally. It sounds very complex, but yeah, that makes a little bit of sense. Thank you. So I feel like when CBD products or hemp products first came out, they were on the shelves of every store, and you would see these bottles that say contains 1,000 milligrams of hemp extract, but it didn't necessarily tell you how much CBD or anything like that was in it. And I have had a similar feeling about other products I've seen lately at times. Have you guys ever tested anything that you were really surprised by how low it was, or maybe it didn't have anything at all? Or have you guys validated any products off the shelves or anything like that?
Yes to all of the above.
Yeah. Yeah, this is one of the things that as scientists really, I mean, personally, it really annoys me because it's disingenuous marketing. Where, you know, somebody can say, I extracted this much, but if you did the extraction in a way that didn't actually get any of the compounds that you wanted, there's really nothing in there. And so you're just saying the work that you did, but you're not actually saying the product that you made, right?
So go ahead. So early on, when there wasn't a lot of testing available for these compounds, you know, I'm talking 2010, 12, 14, before any of these cannabis labs came about, nobody really had a way to figure it out. So they would say, I extracted this much biomass, and then I put this much of that in a bottle. So this is equivalent to 1,000 milligrams of cannabis leaf or cannabis flower, right?
Yeah.
Because no one could verify it. But now that there's labs in place, you can verify it. So there should be no more marketing like that. It should be marketed on active materials, not what I started with. Because I've seen, for example, in the mushroom world, I've seen people bring mushrooms that test at, you know, 1 milligram or less per gram. And then I've seen some test at 30 milligrams per gram. So if you give someone that biomass and you're like, eat a gram, one person's you eat one of those, the real low one, you're not feeling anything. You eat the 30, you're feeling it, you know.
You're right. And it also depends on the compound too. Like cannabinoids, for example, you know, those are super easy to extract from the plant. If you put cannabis and alcohol, you're going to get all the cannabinoids out of there. But with some other mushroom compounds, that's not the case. And especially when we're trying to get like a full spectrum extract where it has a variety of things, some that are polar, some that are very non-polar, one extraction isn't going to really do it. In the case of cannabinoids, they all kind of have the same polarity, and you're going to get all of that stuff with the simple extraction, but it's just not the case with other kinds of.
And also the thing that makes cannabis so easy too is all of the materials in the trichomes on the surface of the flower, you know, like 90% of it. Whereas for fungi, it's embedded inside the cell wall of these very strongly protected fungal cells.
Yeah.
So we use sonication for some of our extractions to make sure that we burst open all the cells, because on a small scale, it's really easy to use.
I also want to touch on sonication. There's a big difference between using a probe sonicator where it's, you know, immersed in the liquid and has a probe that's directly agitating it versus having it like immersed in a sonicator bath. The sonicator bath is not nearly as effective as the probe style.
That's for cleaning jewelry, not for breaking open cells.
Yeah. And so how much more efficient is sonication over agitation?
It depends.
It depends. One thing that it's going to do is, if your efficiency depends on time. So if you want to get that done quickly, the sonication is going to rupture all the cells, and then your extraction is going to happen in minutes versus in hours. If I don't know the answer to that question just off the top of my head, but I would expect if you were just agitating that it would take quite a bit longer to fully extract, because you're going to have to wait for your solvent to diffuse all the way into the interior of whatever the particle is, and then dissolve that compound, and then diffuse all the way back out.
Yeah, I've done experiments when I first started the lab where I, on a shaker, had psilocybin biomass for 24 hours, and I would take the same sample and I would shake it for 10 minutes in the same in methanol, and then both of them are in methanol. And then the 10-minute one, I take it out and I sonicate it on an ice bath for 10 minutes, and no matter how long I shake that other one, I always get 10 to 20% more from the sonicated sample. So you never get it all out on a shake, in my experience. I know there's some people might have a little bit different method. Like there's other labs that don't use sonication. Rose City, for example, does it, and they get really good numbers. Flourish was part of like a blind PT test with a few labs a couple of years ago, and Flourish and Rose City, and there was one other one. I'm sorry, we all tested very similarly. So everybody's, getting pretty good results no matter how they were preparing the samples. I don't know how other labs do it.
Totally.
I know Rose City doesn't use sonication, though. I asked.
One of you guys just mentioned that like the mushrooms are a lot harder to extract than cannabis, as an example. And it sounds like things like sonication can help. But what about like heat and like diterpenes and triterpenes? Have you guys noticed them to degrade with heat, or is heat a good option for mushroom extraction of di and triterpenes?
Probably for those larger terpenes, it's okay because heat absolutely depends on the thermal stability of the molecule in question. And one thing that's interesting, we have the most experience with lion's mane in terms of extracting hercinones and erinacines, which are di or triterpenoids. I don't know which one. I think they're diterpenoids. But you have to use heat, hot ethanol, or it doesn't come out. And if you use a little bit of water in there, it knocks down the extraction substantially. So, and for things like beta glucans, there are these huge polymers that make up the cell wall of the fungi. Like you have to use hot water to get those out, or acid or base, or there's certain extractions that require heat.
Right. And I mean that it just makes basic sense if you think about, like, if you wash your dishes in cold water versus in hot water, same thing with clothes. It does a better job because hot solvent is better at dissolving things. The solubility of pretty much everything is higher in warm solvent or hot solvent than it is in cold. And I'm including water in that description of solvent as well.
Would you need to worry about degrading the compounds?
So that would be the next thing that I'd say is if, as long as your compound is heat stable, then higher heat is going to give a better extraction efficiency and a faster extraction. But in the case of things that are potentially damaged by heat, then that's something where you'd either want to do R&D testing to figure out how hot can I go before I start to see degradation, how long. It's always about time and temperature for those things.
There's a really good example for that one, Amanita. So, basically have ibotenic acid is decarboxylated to muscimol, just like THCA is decarboxylated to delta 9. Mm-hmm. And it requires heat or light or something. But Eric and I actually did some extractions a little over a year ago. Boiling it, but there's this, you definitely lose a ton when you're doing it. We couldn't fully convert without damaging it too much. We didn't put a ton of effort into it. We decided to move on to a different project, but it's just one of those really tricky ones, to the point where I know people that like they gave up and decided to make synthetic muscimol so they could make muscimol products.
That is very interesting. It seems like one of the biggest hurdles for people wanting to get in extractions or like seriously do it is solvent recovery. Is there any other options other than a rotary evaporator for solvent recovery?
Well, not so the nice thing about a rotary evaporator is that you can do your evaporation at reduced pressure, and it's all self-contained inside of there. There is distillation. You could do distillation in a distillation apparatus. Well, that's going to be even more expensive. I think if the issue is cost, then I would recommend looking for a used rotary evaporator, something like that. Like that piece of equipment is specifically designed to do that task extremely well. And the alternative would be something like using glassware to basically do the same process as what the rotary evaporator automates for you.
Totally.
There's other technologies that I was mentioning real quick in his ear. They're much more expensive. There's a thing called a falling film.
Mhm.
They do a great job, but you need to have a lot of capital to get those put in place.
Right.
You can get a good rotovap a big rotovap that can do 5 gallons in a couple hours. You could probably find one of those pretty reasonably used. So you just got to look around.
Yeah.
There's a lot of that equipment out there from CBD labs sitting empty and stuff like that.
There are also other techniques that are like, for example, like reverse osmosis for water. You can also do the same thing with organic solvents, but those systems are also very, very expensive. So, and I'm talking like tens of thousands of dollars versus a rotary evaporator, which could be a few thousand.
It'd be a good investment, I'm sure. Can you guys tell us a little bit about ergosterol and ergothioneine and maybe some of the results you've seen from testing for it?
Sure. So ergosterol is it's basically a vitamin D-like compound in mushrooms that's really common, found in the cell wall. Some species have a lot more than others. Specifically, reishi has quite a bit. And it's just a lipid, essentially, that I believe if we eat it, our body turns it into vitamin D, but I could be wrong. If not, I know it functions like vitamin D, and it absolutely is a vitamin D-like function in the mushroom itself. We haven't tested a ton on maybe a dozen samples or something like that. It's not a super popular compound that people have asked us about, but I mean, every time someone's asked, it's been there. It's fairly abundant. It's pretty cool. I think it's a really interesting compound. And then ergothioneine is really common in oyster mushrooms, and it's also in lion's mane and some other mushrooms. It's actually a modified amino acid, and I've read a couple articles that claim that it's a highly important compound for our physiological function. And one of the best places to find it is mushrooms. And I think it's found in some other plants as well. But they're kind of obscure. And again, there's a lot of it in these mushrooms, like, milligrams per gram.
Ergothioneine has stability issues, though, right? Is that the one that degrades and that you had degrading with oxygen in the vial?
No,
Okay.
That's some other.
Sorry,
No, it's okay.
Didn't mean to confuse you. Sorry.
I think that one's actually pretty stable. It's a water soluble molecule, and it's just like an amino acid. So pretty interesting, though, that there's some literature out there that claims that it's highly beneficial for human consumption.
And what about I'm pretty interested in lion's mane. I've heard quite a few other people who are. I know you guys aren't like neurologists or anything, but can you give us an idea of what a neurogrowth factor is? I think it's called that.
Yeah,
people are saying that.
This is actually a personal passion for me, the neurogenesis side of all this stuff. Like, I've had some family members deal with some neurological issues, and I have had lots of concussions being a skateboarder and a wrestler and other stupid things that I've done. So I've always been concerned, and I've got some Alzheimer's type stuff in my family, although I just want to say on record, I don't really believe in the genetic part. I think it's mostly environmental. But it's something I'm very concerned about. So I got interested in lion's mane several years ago when Paul Stamets started talking about the psilocybin lion's mane combination that it's erinacines and psilocybin cause a synergistic effect in neurogenesis. And then, of course, he was always big on talking about adding niacin, a B vitamin, with it as well, because that's a vasodilator. And the whole point of like dealing with neuropathy or the type of getting these molecules deep in the brain, they have to get to the ends of our blood vessels and get through the blood-brain barrier. And so what the niacin was do is it opens up our blood vessels. It does not open the blood-brain barrier. I want to be specific about that. But if you're dealing with neuropathy in the fingertips, the feet, people with diabetes, any type of neuropathy, that B vitamin helps get the psilocybin, it's actually psilocin, the psilocin and the erinacines that actually initiate neurogenesis. Now, what you're talking about with the neural growth factors is the mechanism by which these molecules turn on the neurogenesis. So it's not that the psilocin and psilocybin go in there and like cause neurogenesis themselves. They turn on growth factors within the genetics of our body that then tell the cell to have neurogenesis like activities. So this is a lot more in my wheelhouse with the biochemistry and stuff like that. So, and also something I'm tremendously interested in myself. I don't know the names of all the growth factors, and I don't have that up on the tip of my tongue or anything, but that's essentially how it works. You know, we ingest these compounds, the B vitamin, or there's even some other cool things you can use. There's peptides that are vasodilators, because niacin, if you take too much, you get a niacin flush. I don't know if anyone's ever had that. I definitely did that when I was experimenting with this combination. But there's other things that you can take to vasodilate that aren't going to give you that niacin rush and stuff like that. So there's a couple peptides out there that I think would be really cool to combine with psilocin and erinacine, or I'd go with the lion's mane extract. I wouldn't really try to isolate it's a mycelial extract too, because the erinacines are in the mycelium, the hercinones are the ones in the biomass of lion's mane. So there's a distinction between the expression of these molecules in the mycelium versus the fruiting body.
And so do hercinones that are found in the fruiting body have a similar effect, or are they not as much so?
No, they don't have a direct effect on neurogenesis. I know they're really, this is something I should have looked up first. I apologize. If anybody listening has some of the knowledge on what the hercinones do, you please chime in later, because that's actually something I meant to check. But we've been so busy doing a couple other things, I apologize. I forgot about that. But they are very good for neurological health, I believe, but I don't think they contribute to the exact same mechanism and function that the erinacines do.
So I will say that those two differ vastly in their polarity. So erinacine is quite nonpolar, or quite polar, and the hercinones are very, very nonpolar. So one extraction is not going to get both of them if you're making an extract.
Interesting. Wow. So have you found a good erinacine extract then, or have you found a product worth taking?
Haven't done that. I did check one brand and it didn't have anything in there, but I'm not going to call out who it was. Very popular.
Totally. Yeah, I'm also very interested in erinacines, and it's hard to find, like, if you wanted to take a milligram of it or something, it seems almost impossible at this point.
We, in the background, we are very interested in lion's mane here, and one thing I would love to do is grow enormous vats of mycelium and extract the erinacines and create a product that has both the hercinones and the erinacines in them, because we could get hercinones a lot easier because everybody's growing lion's mane biomass. Most people
Fruiting body.
Yeah, because they're both biomass, correct? Thank you. The fruiting body. But most people grow them in a media where it's really hard to recover the mycelium. So I would like to do liquid vats of just growing mycelium. It's basically cell culture. That way you can pull that out and purify. There's no soil, there's no grain, there's no nothing.
Yeah.
Just liquid media.
Hopefully someday. Okay. A lot of people I've heard of complain about their psilocybin extracts. They feel like, it doesn't even seem like there are a lot of psilocybin extracts. I don't know if that's because it's tricky to extract, or if maybe psilocybin is particularly unstable. Can you guys speak to that at all?
Yeah, that's mostly what it is in my experience. First of all, the main function that I've seen for the extraction of mushrooms for psilocybin isn't to make a super concentrated extract that you can like, oh my God, it's so concentrated, because you only need 50 milligrams of this stuff to really get a macro dose, right? So The main function that I've seen people doing extractions for is to remove the mushroom biomass because it makes a lot of people sick. And then also to remove the mushroom flavor when they're making gummies or chocolate bars and stuff like that. Because most of the extracts that I've tested are barely more potent than the biomass, than the mushrooms themselves, if that makes sense. And then also it's highly unstable. And a lot of people extract it and they leave this wet goo in there and it just degrades.
Interesting.
So you'll see, I've seen some really large discrepancies in the quality of different psilocybin extracts. There's a couple people that can do it really well. And most people struggle and send us these gooey orange. And to be honest, like that's fallen off completely. Hardly anybody's testing those anymore. Because I don't know if people figured it out and they got their process or they gave up because it wasn't worth it. But yeah, it can be done. It has to be done correctly. And like some of the stuff Eric was talking about earlier, with using the right extraction solvents, right methods, and then like taking out that contaminant right away by washing it with a different solvent. Because one thing that can happen is when you do an extraction from an organism, a lot of times you pull out lots of stuff and you need to process it further. It's not just, oh, I extracted psilocybin, I'm done. No, you extracted everything that solvent would pull from that organism. And now you can use, for example, a wash with a different solvent to wash away either the contaminant and leave your goods behind, or you can wash away your goods and leave the contaminants behind and then go recover your goods. So it just depends on what works best. And that's why the R&D comes in, and you have to be really careful about testing all this stuff systematically and writing it down so you can go back and figure out what you did and do it again. So possible, but challenging.
Right. And keep in mind that our experience with this is not as large scale extractors or anything. It's just we get the product that's the end result of whatever a customer was, whatever experiment they were running or whatever process they're doing. And then we can give a little bit of advice there, but without really having the knowledge of what they did, what their SOP was to produce that material, it's kind of hard to judge on that. In the lab, like I said before, we're just interested in making sure that we give you a number that represents the actual content of your material. And so our extraction is more tailored towards getting everything out, including the psilocin or psilocybin or whatever, and then being able to analyze it and give an accurate number, not so much on how to actually produce a quality extract from for sale or anything like that.
Which we have consulted with lots of people to show them how to do that as well. We can do both,
Yeah.
We understand both workflows and processes.
Yeah, with some knowledge of what's going on, we definitely understand the chemistry involved. We can give advice, but it's not like neither of us have made large amounts of psilocin or psilocybin extracts ourselves.
We've helped enough people that we know how to do it, though.
I would bet.
It's just not what we do. Yeah.
So what about some of the other compounds in Hericium, Ganoderma, Cordyceps? I mean, can you elaborate on the stability of any of these things, like even relative to psilocybin or cannabis, THC or something like that, even maybe beta glucans, polysaccharides?
Yeah. So most of those that you said at the beginning, the cordyceps analytes tend to be very stable. Now this is in a tube in the fridge, right? Or in a sample on a shelf. They're being protected from obvious degradatory mechanisms like light and oxygen and heat, right? It's cool, dry, or cold and dry. But the ganoderic acids are also pretty stable. The chaga analyte, inositol, that we look at is highly unstable.
That's the one I was thinking of earlier.
That one sucks. The very first time I bought that reference material, I spent like $500, and I worked it up, did the calibration curve, tested the sample, and then that was like the first time that someone asked. And then a couple months later, I got another order, and I went to go test the control sample. It was just gone. I went to the freezer sample, gone. So it's super, even in the freezer, it degraded because I left oxygen. So I have to get, we have to get a little canned, argon or nitrogen. And when we're done with that, or when we make it up, we blanket it to get rid of the oxygen, tube it, cap the tube, wrap it, and put it in the freezer. Then it lasts great for months. But it's just, it just depends on the molecule.
Okay. So you guys can test for some of the stuff in Amanitas. Can you test for the stuff that is poisonous or whatever?
Yeah, that's the ibotenic acid.
Yeah, that's so.
Okay.
Our Amanita test is muscimol and ibotenic acid. Those are the two compounds that we report out of that.
Okay, and the other one is the psychoactive one.
Muscimol.
Muscimol is
Okay.
There's another compound in there called muscarine. I haven't been able to find a reference material for it, which is why it's not part of the test, but it's something else you can test for if you have like an LCMS or something. You can look at the maths and to charge ratio and how that works. But yeah, there's a couple other things in there that are a lot less well known, but those are the two big ones: ibotenic acid and muscimol.
What's one of the most unexpected results you guys have ever came across? If you can share it.
I can think of one.
If there is one.
So this is a psilocybin mushroom. Most of the samples that we get in here, some kind of PE variety, some kind of, or cubensis variety, I mean. And the most potent that I've ever seen of that was an ape that consistently tested at 20 mg per gram or 2%. And then there was a sample that someone brought me. It's not cubensis, it was psilocybe.
Azurescens.
No, not the as. It was the really skinny stem, long. It grows on the University of Washington campus. That was 30 mg per gram, 3%. It's by far the highest mushroom I've ever seen. I'll think of the name of it here in a little bit if I can Google it. It's really common. It's
Liberty caps, maybe.
No, it wasn't a Liberty. It's a oh my gosh, I feel silly.
I don't remember.
That's just a wild mushroom testing
it's just
higher than like a
mushroom that grows in the
domesticated.
Pacific Northwest. Yeah.
Wow.
It literally grew for years on the University of Washington campus. At the police station, they laid down a whole bunch of wood chips. And for decades, people would go harvest mushrooms in front of the police station at the University of Washington campus. And then now the police station moved to a different building, but all the bark chips are still there. I went there a couple of years ago in fall, and I saw just a huge flush. And I just laughed. It was awesome. It's really common, though.
You're saying cyanescens? Is that
yes, thank you. Yes.
Okay.
Yes,
Right
that
on.
was it. Somebody else knows about that, Pat.
Okay. So have you noticed any variability when testing the same extract from the same batch, or even noticed inconsistencies between labs working with the same samples? And what might be some of the issues that testers might be experiencing?
For the most part, if I've had people in the past there were a few guys that I worked with for quite a while they developed their extraction protocol for psilocybin and psilocin. And to be honest, they were pretty consistent, man. There wasn't a lot of, they were all careful, so they didn't let it degrade needlessly. And I've had stuff that I've kept in the fridge or on the shelf for a while and go back and test it, and it seems to do okay, as long as it's sealed up and dark and dry. But different results from different labs, my word, yes, of course. Like I've seen a couple things that just blew me away. Like there's another lab where they were saying they were getting Amanita. They were getting psilocybin to make they were getting Amanita to make psilocybin. So that they said that they could, it was cross-contamination. They weren't cleaning the machine enough. And then they're reporting this to like people that they have this and that it's a real thing. I couldn't believe it. And then there's of course the if there's ever any unregulated industry, people are going to scam it. And so there's other labs that will just inflate the numbers just because you ask them to. It's something we would never, ever do here. Like, in my opinion, the only thing a scientist has is their honesty and integrity. If you're going to fake data or fake results, you shouldn't be a scientist. That is ridiculous, in my opinion. And it kind of pisses me off because it puts people and labs that are doing it the right way in a tough position, because if you're going to bring me your sample and I'm going to give you a number, but you want to hire one, so you go somewhere else that'll give you whatever number you want, that's just not good for business. You know what I mean? People that are doing the right way are, because they're going to be like, oh, go here, you'll get a higher number. You know, but why? So you can have a wrong label on your product? That just makes no sense to me, but I'm a very logical person.
Yeah, and not to say that it's always malicious when you see variability between different labs.
Definitely not.
You know, so different labs can and do have different extraction procedures, and it may well be that they are doing their best and they just don't know that there's a problem. So, you know, it's as scientists, like George said, we all we do is do our best, and you know, it can be that there's something that is incorrect about the way that we're doing something, or maybe not, you know. And so it's hard to say, but like George said, it's incredibly frustrating when there are bad actors in the field. You know, it's really hard to compete with somebody who makes up numbers.
Yeah. I mean, everybody makes mistakes. We're all human, for sure. I've made them. I've had tests where I've had some issues and someone's like, oh, I don't think that's right. And then I dive into it and I'm like, you're right. It wasn't right. And then they get a free test, you know, no big deal. I give up a free test, but I know my test has improved.
Right. And we learned something out of it.
Yeah.
You know, we learned that we won't make that mistake again. That's what science is all about, is growth and investigation of issues.
That's trust the science. Trust
Right.
the science is never trust the science. You know, you always, if you have new evidence that comes along that proves you wrong, you can't be a stubborn, egotistical jerk and be like, I am right. I don't care what you say. I mean, that's the kind of stuff we see prolifically happening in our world today, but like not here. We're open to being wrong.
Yeah. Yeah, totally. So, and I guess testing isn't like a perfect science, and like I know things like the Miraculous. Are you guys familiar with the Miraculous Q tests and stuff like that? And I was pretty skeptical of those at first, but I've heard that they can be pretty accurate if you use them right.
Well, they've put in a ton of R&D, man. Those guys have worked really hard to develop it. I remember when it first came out, I looked at it and I looked at the numbers they were getting. I was like, so like you, I was a little skeptical. But within like 6 to 8 months, they tightened up their air. They were getting way better results. Like, I think that is awesome because not everybody can afford a lab test. And, you know, if someone wants, even if it wasn't super accurate, if it was close, that's really good. But I think it's actually a pretty good test, to be honest. I'm not going to say anything bad. I've never seen anybody complain about them being way off. I've only seen people get fairly accurate results with them, if not right on. So I think it's a really reliable test for a home tester.
I mean, what would you, I guess, like, if you're getting your product tested multiple places or even using a Miraculous and you might think it's not like 100% accurate, I mean, what kind, is it safe to make like assumptions, or can you come to pretty definitive conclusions from HPLC, you would say, generally, compared to something like mass spectrometry, I think it's called?
Yeah, so HPLC is the front end that does the separation, and then the mass spectrometer or a UV detector or whatever is simply a detector that detects the things that are coming out of the HPLC. So any MS like that is going to be HPLC-MS, just like HPLC-UV.
Or GC.
Or GC-MS, yeah, exactly. So the separation technique is what is going to separate the molecules, and then the detection technique, whether it's MS or UV, simply quantitates them. MS can be better for certain things like detecting super, super low levels of compounds, but both of those techniques are just as accurate as far as quantitation.
It all depends on your standard curve,
Yeah.
the source of your reference material. So if you're started with certified reference material, you know that is a really accurate compound. You make a calibration curve with that. It doesn't matter which machine is using it, it's going to reference that standard curve.
Yeah. So one of the major concepts in laboratory accreditation is tracking your error. So like how much potential error there is in the final result depends on all of the individual sources of error that make up that result. So that can be weighing out your sample. How much solvent did you extract? Did you measure it with something that has an error associated with it? And if you diluted it, when the instrument does the injection, how much does it inject every time? If you were to inject the same sample over and over and over again, how much variability do you have between those? How accurate was the standard that you're using to make those curves? And then you put all of those together, and that gives your overall error. And so to answer the question about the UV versus the MS, it's only one part of that. And I would say that it's a very, very small part of that overall error. You're going to find a lot more error in things like sample preparation, extraction efficiency,
liquid measurements.
Exactly, liquid and solid weighing measurements, that kind of thing.
Yeah, one thing that Eric was just describing really is really critical. It's called a validated test, right? So one of the jobs I had just recently before I left and only working for myself was an R&D position at a lab called Molecular Testing Labs, where we were developing clinical tests under CLIA, which is a clinical laboratory accreditation regulatory body. Every single test has to be validated. So when you develop a validated test and you're done with that, you know that's rock solid, and you can take it to your regulatory body and be like, yeah, look, I know it's good.
Yeah.
You know, and whereas sometimes you can just make a one-off test, like, oh, say we get a reference material and we do a calibration and we run it one time, we're like, oh, that's a test. I mean, it works. It's not a validated test. It's not going to put up to the scrutiny of having all this data behind it to show how much standard error you have in that test based on how you've done it. And that's what a validated test. And that's when you know, oh, I'm allowed 8% plus or minus error, otherwise it fails. Whereas like a non-validated test can be like 20% either way before it fails.
Mm-hmm. And another thing to consider is the ruggedness of a test. So it's really easy to come up with a test that works perfectly with a pure compound, but does that actually work when we try it with real world samples? So yeah, it's something that each testing lab has to look at when they're developing their protocols.
Perfect example of that happened when I first started, when I did the Amanita test. When I set up all the psilocybin stuff first, it worked great. It, you know, run mushroom samples, gummy samples, chocolates. I was getting resolution, meaning no overlapping peaks for the psilocin and psilocybin. And when I first set up the Amanita test, I had two peaks running together. So I was inflating the muscimole. And that's earlier I talked about a guy saying, oh, I think it's not correct. There was a customer saying, I think this is way too high. And I was like, so I started messing with the test. And then I was able to separate those two compounds. And I was like, he was right. And I showed him the data and everything. And it was great. It helped both of us because now he was getting accurate results. And I know I was much more confident in the test.
Wow. That's awesome. Yes. So where do you think all the mushroom testing, or just all the testing really, where do you think this is all going to be in 5 or 10 years? You think there's going to be some advancements? It'll be just the same, or what'll the industry look like?
Technology or industry?
So yeah, as far as as far as the testing technology, I mean, the testing methods that we've got now are the same ones that are used by pretty much all the labs. Because
most of these have been around for decades.
Because they work and they're effective and they are economical and give correct results. So when those are true, there's no real reason to change it a whole lot. So the things that I would see, like as far as analytical lab testing, I don't see it changing a whole lot, but I could see more things like at-home devices. I remember when cannabis testing was first coming out, there wasn't really a way to test cannabis materials at home. And then there started being like light-based detection systems. Some of them are less reliable than others, but that technology has come a long way, and now there's affordable options for people to test at home without sending a sample off. I'd love to see more of that kind of developments in that space.
As far as the mushroom world goes, I would love to see the functional mushroom space get a little more rigorous on having products tested. Not only because it would benefit a lab like ours, but because a lot of things out there don't have anything in it. You asked earlier about lion's mane and testing products. I did have a customer send me 3 different chaga products and pay for the testing of those. And only one of them, the Real Mushroom Company, was the only one that had inositol in it. All of them looked flat and that's why I think there should be some regulation around it, because there's companies out there making money hand over fist selling you fake products.
Yeah,
Or products that they are doing something that they think is working, but it's not actually extracting what they think they are.
But if they were testing
Yeah.
it, they'd know.
Exactly.
yeah, absolutely agree with that.
A little
What about your guys' business? Where do you think you guys might be in 5 years? Are you going to have another couple dozen chemicals you're testing for, or?
Yeah, we're looking to expand our capabilities, expand our instrumentation, have
get accredited as well.
Get our accreditation, and then have a full service facility where we can do not only this kind of testing, but also things like food safety testing for finished products. That, you know, lots of stuff like that. That's our passion.
Well, that's pretty much all I got, you guys. I was going to see if maybe either of these guys had a question to ask you, maybe, if that's
Sure.
okay, if we have a minute.
Absolutely.
David, you have?
Yeah, I did. I had just one question, I think, and it was relating to the stability of these compounds. Or no, actually, it was about when you're extracting them out. You were talking about using heat is really necessary to get the arenaceans out of these hard cell walls. What about just time? Because I know a lot of people, when they're making an extract at home, they'll like soak it in the alcohol for months on end. Does that have any play in it, or is it
I think the customers would be a little upset if I told them it was going to be 3 months before I got their results.
right?
Our turnaround time is 5 days.
Yeah,
So
and that's amazing for what you guys are testing for. But would it be effective for someone at home to do that?
Absolutely. If the molecules are stable and not going to degrade over that time, I've had customers that took their mushroom biomass, grind it up, put it in alcohol, and then put it in the freezer for like 2 weeks. It works. If you have the time, absolutely. If you're just making a tincture at home, 100%. Now, I would offer that after you make that, you might want to call us and make sure that it worked, because it may not have, and then you're going to be taking alcohol with nothing in it.
Yeah.
You know, and another
$75 to find out. So
another thing to think about is the solubility of different compounds. So like George mentioned, if you have even like 95% alcohol is not as effective as 100% ethanol, and that is due to the solubility. So if you're not able to get it in solution at whatever temperature, soaking it for longer is not going to make it better. It's just going to soak it longer for no reason.
Yeah.
And in the same theme, if it's not soluble in that solvent while it's cold, if you manage to heat it up and dissolve it while it's hot, it's going to come back out of solution as it cools down, and you won't have anything left in there. So the solvent choice is very important.
Cool. Yeah.
Did you guys have anything? Oh, sorry, David, go ahead.
No, it's all good. That was my only question, and I did want to say thanks for taking the time to do the interview.
absolutely, man. It's been fun.
Yeah. You guys have, George, Eric, you have anything you want to add?
No, I mean, I think we covered a lot of topics. I feel like I've shared quite a bit.
Yeah, it was a pretty thorough question base. That was good.
I felt like I learned a lot. I really appreciate it, you guys. Thank you so much. And on behalf of the Mushroom Group and anybody who might watch this, thank you so much. I think we're done here.
Well,
Please-
thank you guys.
Please reach out if you've got any more questions. We're happy to talk to you.
And if anybody hears
you
this
so
and you
much.
think we can help you, give us a call or, flourishlabsoregon.com. And our emails are on there, so you can hit us up.
Hell yeah. Thanks, guys.
Thank you.
Thank you.